Okay, so students, remind you again about our test today. Okay, so the test today is after our class, 4:45. Okay, so I will try to finish up at 4:30. Okay, or maybe 5 minutes earlier. Okay, then so okay, then for example, for your information, the answering time is 1.5 hours, and then additional 30 minutes for your submission. So exactly same like how I schedule for your mock test. Okay, but the difference is for your mock test, you can submit late. Okay, so for your test later, you cannot submit late. Okay, it's by 6:45. And please make sure your answer is actually compiled according to the sequence. So you should have enough time to actually compile it properly. So far, when I check your solution all in Words file, because if let's say you don't submit in Words file, it can't be submit in the Moodle, okay? And I also realized as a student submitted with the multiple files, actually you can just upload one file, like 5 pages, you just compile as one PDF file and submit. So try to submit by, okay, even though the due is 6:45, but try to submit by 6:30, okay? Because I don't want, as I say, Moodle need time to upload, okay? When you upload the file, it may need time. So don't submit it last minute, okay? And students, just in case, okay, just in case, later when you have a submission issue, okay, just in case, okay, so you can, worst come to worst lah, okay, before due 6:45, you let's say something's wrong, suddenly something's wrong with your internet, okay, so I don't know, or maybe Moodle very slow, okay, so then worst come to worst, before 6:45, you can send your file to me in the personal chat. Personal chat. Don't submit in the team. Team, sorry, it's not in your team, but it's a personal chat to me. Worst come to worst. Okay. And in case there's anything happen, you have to always think that you must keep the evidence, okay, to show me later. Okay. Else, this is assessment. Okay. Because students always tell me, Miss, ma'am, trust me, I'm actually have this issue. I don't copy, so please accept my file. So I think students have to understand this is not, when come to the assessment, this is not about the trust. We can't just based on the trust. It based on the evidence. Okay. So for your information, you should know that all your submission, what time you submit, is already in Moodle. Okay, so if you submit 5 minutes late or 10 minutes late or 1 hour late, is all in the Moodle. So everybody can, when they come to the Moodle, they can see, okay? If the moderator or anybody, when they come Moodle, they can see. So, okay, in case you have any issue, you must think how to show the evidence to me after the test, okay? So you just take note about this. As I say, in case there's something or some problems with the Moodle, worst come to worst, you can submit your file to personal chat before it's due. Okay, before it's due. So then, of course, if let's say you have issue, you can text me. But for your information, later I have class until 6:30. Okay, so if you have any issue, I can only look into it after 6:30. Okay, but your submission is until 6:45. Okay, in case any issue, you can send the personal chat to me. Don't, some students, they have questions. So they just ask very open in the team, cannot. Okay, so you have to put it in the personal chat. Okay, is there any other thing about the exam later? Okay, so let me look at the one given by, okay. Yeah, this kind of the question is possible. So that means without diagram, is it? Yeah, it's possible. So that means this is still under trigonometry, okay? So it's just, they don't give you a diagram. So they describe everything in the question. then of course you need to understand, okay, what is actually being mentioned in the question. Then you may, normally the triangle, okay, so of course based on this question would be easier for you to understand if you draw up the triangle and so on. But for your information, normally the triangle won't contribute any marks in your test or exam, okay. But for you yourself, okay, sometimes because the questions don't put the label or something like that. Based on the problem, when you draw a triangle, you may need to label it, and then your workings will based on that label. That would be easier for me to understand when I mark it. Okay, so for me to understand better, lah, right? Okay. Okay. So yeah.
I am the one who sent the multiple files. I don't know how to submit so many images into one PDF file.
Okay. So actually, many online. Okay, but this one you better try earlier. Okay, there are many. For example, you have images. Okay, convert. You just open a browser. Okay, then you just look for convert images to PDF. Okay, for free. So there are many websites is actually can use to do the conversion. For example, I just simply click one, and I've been trying for this one. Okay, so let's say you have snapped 5 photos. There are 5 images. So you can just drop the 5 images here. Then it will convert to one PDF file for you. Then you just download it. Okay, so you better try this. Okay, just in case you never tried this before, you're not familiar, then I can still accept the multiple PDF files lah. Okay, but there's a limit for number of files. But I just suggest you this. Okay, if you have time, you try before the test. If everything can work, then maybe you can use it during for the submission later. Okay.
Thank you so much.
Okay.
Yes.
Yes. Okay. For your information, some students, if let's say you put in the words file and then convert to PDF file, you have to be careful. Okay, because I realize some students in one page, right? One A4, normally A4 size, right? A4 page. Students, they put few images in one page. So it's very small. So when I open it in the Moodle, is very small, so it's very hard to check the solution. This is one thing. So, or some students, they copy one image in the words file, but the image, right, you should drag it to the max, okay, within the margin. So sometimes the image, when they copy, is small, so they didn't drag it to the maximum size of, that means fit to the A4 size, one page, okay? So they just leave it with the original size. It's also very small. So it's very hard for me to actually mark it when I open it in Moodle. For your information, if I download the file is clearer. I can see it clearer. But when I open in Moodle, it's actually a bit blur. Okay, for your information. Okay. Yeah, some actually they can, handphone, they have scanner, and they can convert to PDF file. So as I say, there are multiple ways lah, okay? So basically, you all can share with others how you all actually do it. The faster way also, okay? Try to use the faster way. And since I don't require any template, so because I realize some students, they create the template or they're using the EMTS template they used before, and then they try to copy, put it nicely, change it. Okay, so during your test, you may not have this time. So since I'm not required this, okay, you can just submit all the images. Okay, but make sure you arrange it lah. Okay, so you should arrange it. Okay, it will be easier. Okay, else it's difficult to mark. Okay. Yeah, that's my concern. And of course, there are 2 students actually, I give them the comment in the personal chat after I check the file. Some like the writing is too small. I don't know why. So when it's open, it's hard to see. And then some is not clear. Some maybe is the how you step your photos lah. Okay, so I always found some students, the photo they snap is very blur. So when you upload, it's also very blur, okay? Just make sure. So far, I think the angle you take the photo is fine because normally we should take the photo from top of the paper. It's not from the side of the paper, okay? So all these things you just need to take note, okay? Okay, so if nothing else, then I will move on to the new topic, okay? As I say, life have to move on. We cannot always stay with the first topic, okay? Since our classes affected by some holidays. Okay, now, I think I asked you to practice some questions. I confirm number one. How about number two? Do I ask you to do number two, student? Do I ask you to do number two? 1 and 2. Okay, thank you, Samuel. Okay, number 1 and number 2. Okay, so number 1 and number 2 is a simple one. Can I have somebody to give me the answer for A? Okay, I just want the answer for A. And then for B, I want to see the simple solution. Okay, so can I have someone to give me the answer for A? Okay. Okay, so can I have, okay, maybe this round I should call from the middle. Okay, Kwa Junho. Okay, can you type your answer in the chat box for questions 1A? Questions 1A, okay, questions 1A, type your answer in the chat box, or you want to snap the photo, whichever is easier for you. Okay, if you're using your handphone apps, then will be very easy. Okay, at the chat box, you just snap the photo and post it. Okay, so is that okay, Junho? Okay, yes. Okay, for B, I would like to have a simple solution because I want to see how you get 2A and 3B. Okay, and also for C. Can I have another students here? Jing Yan, Lim Jing Yan. Parrot. Okay, okay. Okay, snap the photo. Then next. Okay, so number 2 is a multiplication. Okay, so for multiplication, okay, remember something, okay? Not all the metrics can be multiplied, okay? Okay, so remember, okay, when come to multiplication of the matrix for your recap, okay, let's say we have matrix A multiply matrix B, right? So let's say you have the dimension of the matrix A as n by n, and the dimension of the matrix B as n by P, okay? So remember, you have to make sure that the number of columns for matrix A, first matrix, must be the same as the number of rows for second matrix. Then they are valid for multiplication, okay? Then let's say the answers you get, right? Okay, the answers you get is another matrix C, and your matrix C will be with the dimension of m by P, okay? So this is a recap. Okay, so okay, Junho sent the okay answer. The answers is actually -2, -1, 2, and 12. Okay, so it is correct. Okay, so this is a correct answer. So I give a like. Okay, okay, guys, check your answer. A. Okay, Junho give the answer for A already. Okay. Okay, for while waiting for the answers from Jing Yan. Okay, so now for questions B, right? Okay, for B, okay, remember when come to the multiplication of the matrices, students always make some mistakes lah for the multiplication of the matrix. Okay, so when you want to multiply any matrix, so make sure you check the dimension. Okay, So this one is 3 by 3. So this one is 3 rows, 2 columns, so 3 by 2. So for the answers that you have, so can you see they are 3 columns here, 3 rows here? Yes, they can multiply, and your answer should be 3 by 2. And we're always taking the rows and multiply with the columns. Okay, that's how we actually get the answer, right? So I will demonstrate once for B, okay? Then I want the answer for the rest of it, okay? From you. Okay, so for this one, when we take the first row times the first column, I will get the answers in the first row, first column. So 3 times 2, 6. Then plus 4 times 5, 20. Then 0 plus -1 is a 0. Okay. Then second row times first column, you'll get the second element. Okay. Second row, first column. So -2 times 2, -4. Then 6 plus 5, 30. Okay. -3 times -1 plus 3. Okay. So next one, third row times first column. So 7 times 2, 14. So -4 times 5 plus -20. Okay, then 1 times -1 plus -1. Okay, so next one, first row times second column. Okay, so -15. Okay, plus 4 times -6, -24, then 0. Okay, second row times second column. So you get the answers here. -5 times -2, 10. So plus 6 times -6, -36. -3 times -7 is 21. Then the last row times the second column, third row times second column. So -35. Then plus 24. Okay, then 1 times -7. Okay, so let's calculate your answers. Okay, 26, 29, and then -7. Okay. Okay, wait, do I calculate wrongly? Wait. Yeah, correct. Okay. Then next one, -39, -5, and -18. Okay, so check your answer. Okay. Jingyan, where is your solution? Okay, for part B, yeah. Okay, now let's look at yeah. Oh, okay. So for part B, okay, they involve the scalar multiplication. So which is 2a minus 3b plus 4c. Okay, so the final answer, okay, so you multiply each element with 2, -6, 0, 14, 8. So 6, -3, -21, 12. So 4 minus 8 is 0, 16. So final answer -8, 3. Hold on. 27, -20. Okay, let me check again. -3, 2, 0, -3. Yeah. Okay. Okay, students, is it your answer is tally with Jingyan answer?
Yes, miss.
Yes, okay. So, yep. Okay, I give a like. Okay, next one. Check your answer for B. Okay. And can I have the answer for 2A, 2C, and 2D? Okay. So check your answer. This is the answer. Then I would like to have 2A, 2C, and 2D. Okay. Wei Huan, can I have the answer for 2A? 2A, Wei Huan. Okay. Then 2A, 2C. Man Heng, how about 2C? Okay. Saad, how about 2D? Can I have the answer for 2D, Saad? Saad, are you here? Okay. So since this one is quite a simple question, so Wei Huan just put it in the chat box. Huh? Okay, so for A, right? Okay, negative. Okay, now, Wei Huan, check your answer for negative 10. Check your answer for negative 10. Do you find anything wrong?
Excuse me, ma'am, can you go back? I need to see the question.
Oh, you don't have a question. Okay. Wei Huan, check your answer negative 10. You can edit in your answer just now. Okay, Wei Huan, do you realize what is a mistake? Oh, okay, he changed already. Okay, so now is the correct one, huh? Okay. Okay, so I give a like. Okay, so this is the answer for A, huh? Okay, negative 19, 21, negative 3, negative 16. Okay, so this is the correct one. Okay, then for B and, sorry, for C and D. Okay, C from Manheng, huh? Okay, D from Saad, huh? Okay, C from Manheng. Okay, Saad, you get the answer already, huh? Okay, so this is for C. Okay, so 11, 8, 0, 11, 11, 2, 8, 13, 6. Okay, so if let's say you think will be easier for you, then you can write out the solutions like what he did, okay, here, okay. But in your assessment, if let's say you don't show the solution, is fine. You can, from the multiplication, you can directly give the final answer, okay. You absent last week, Saad. Okay. Okay. Then Saad, okay. When you absent, okay, for students, any students that you absent, you need to watch the recorded video. Okay. So because this is online classes, all classes are recorded. To be frank, this is something. This is one of the good things about having online classes. Okay. So all the classes are recorded. So when you absent, you need to watch the recorded video. Okay, Saad, right? Okay, can I have another students to give me this solution or the answers? Okay, so who is the next students? Okay, Ziyi. Is that okay? Can you upload your solution? Ziyi, do you have the answer? Okay, can. Okay, so we just wait for Ziyi. You can't find it? Oh, you'll do again. Okay, it's okay. Ziyi, maybe I ask another students. Okay. You got a different answer for 2A. Before that, you check whether it's tally the question. Do you write the correct questions or not? Because when I look at this one should be the correct one. Row times column. Wait, hold on.
Yes, for 2A, I got negative 19, 3, 26, and negative 9.
Hold on. Okay. So, okay, again, negative 19, then?
The bottom one is 3.
Uh-huh.
Then the top right is 26.
So the only difference is a 7. This one, is it? The one I highlight, is it?
Yeah.
Okay, so 1 times...
Never mind, miss. I think I see wrongly just now.
Oh, okay. So, but just now somebody also clarified with me, right? The answers. Okay. So now how come become negative A already? Okay. Hold on. Because sometimes do we write the correct matrix? Okay, it's okay. We check again.
As for me, miss, I got 7. I checked the question again. I wrote it correctly.
Okay. So okay. So same answers as Samuel. Okay. Wei Huan. Oh, okay. Okay, let me check again. Okay, so 2 times negative 5 is a negative 10. Then minus 9. Then second row times the first column, negative 5 plus 12. Okay, then first row and second column, 14 plus 12. Okay, then 7 minus 16. So it's negative 19, 7, then 26, and negative 9. Yeah, this one is the correct one.
I got the same exact working, miss.
Okay, right? Okay. Yeah. Okay, regarding D, right? Samuel, do you have the answer for D?
Yes.
Okay. Okay, so we wait for the answer from Samuel. Okay, then we can move on to other calculation. Okay. So, okay, this is the answer from Samuel, 6, 2, 10, 9, 9, 11, 7, 2, 13. Yes, correct. Okay. Okay, students, check your answer. The answer from Samuel is correct. Okay, this is the answer for D. Okay. Okay, so then I will move on. Okay. Previous part, we stopped at the multiplication. Okay, let's continue with this slide. Okay, okay. This is continue with the multiplication of the matrices. Okay, so next one is about zero matrices. Okay, what is a zero matrices? So zero matrices means all the entries, all the elements in the matrix is a zero. Okay, so we call it as zero matrices. Okay, next one. Okay, identity matrix. So when come to identity matrix, the diagonal entry will be 1. Okay, so what it means by diagonal entry? That means this one is diagonal entry. So this is diagonal. Okay, so diagonal entries are 1 and the rest of the elements are 0. So we call it as identity matrix. Okay, so the first one is the 2 by 2 matrix. Okay, the identity matrix for 2 by 2, and the next one is for 3 by 3. Okay, so this is identity matrix. So for identity matrix, it's very common that we're using a capital I to represent an identity matrix. Okay, and for your information, okay, this is important properties about identity matrix. That means when you take any matrix and multiply with the identity matrix, it will always give you back, let's say A, you multiply with identity matrix I, you will get back to A. So if you take the identity matrix multiply with the matrix A, you will get back to A. Okay, so AI or IA, multiplication of AI or IA will still give you back the matrix of A. Okay, so this is the properties of the identity matrix. Okay. Okay, so next, okay, next we will move on to the inverse of the matrix. Okay, so we will go through on how to find the inverse. Okay, so what is the applications on the inverse? What we can apply after we learn about the inverse? So we can using inverse matrix to actually solve the simultaneous equation. Okay, that will be the later part. That is one of the method. Okay, now let's look at how we find the inverse of the matrix. So I think in high school last time, you should have learned about find the inverse of the matrix. But that time maybe it's more involved to 2 by 2 matrix, and here we will involve the 3 by 3 matrix. Okay, before that, let's understand what it means by inverse of the matrix. So if matrices A and B such that A multiply B or B multiply A is actually giving you I. What is the I just now? We mentioned I. Okay, so I is an identity matrix. Okay, in the previous slide, we just mentioned. Okay, I is identity matrix. So when you take A multiply B and when you switch the position, B multiply A, both also actually give you the identity matrix. Then matrix B is called the inverse of the A. Okay, inverse of the A. So inverse of the matrix, we using this superscript of -1 as a notation representing inverse of the matrix. Okay, so if we and then the A is called the inverse of the B, so which is with the notations of B -1. Okay, superscript of -1. That is inverse of the matrix. So that means for your information, okay, so you have matrix A when you want to represent the inverse of the matrix. For A, then we just need to put the superscript of -1. And for your information, there's a properties about the inverse of the matrix. So when you take the matrix A multiply with the inverse, it will always give you the identity matrix. So it can be inverse matrix multiply A, it will always give you the identity matrix. Okay, so this one is the inverse. Okay, so you can see what we given here. Okay, now let's say we in the examples here we have a matrix A and matrix B. So B is actually show B is the inverse of the matrix. So if let's say B is the inverse of the matrix, when you take A multiply B or B multiply A, they will give you identity matrix. So this one is identity matrix. So remember just like I say, the diagonal entries are 1. Okay, but it must follow this direction. It's not follow this direction. It must be this direction, the 1. Okay, then the rest are 0. Okay, now, okay, here is an explanation on what is the inverse. As I say, we can use it to solve the simultaneous equation. Okay, next one. Okay, this one is important because come to the later part under Gaussian elimination method. So a square matrix whose elements is 0 for I greater than j is called upper triangular. Okay, so what it means by a matrix of upper triangular? So can you see this one is a diagonal, right? This one is a diagonal entries of the matrix. So for below the diagonal, can you see all these elements are 0? Okay, then we say upper triangular. Okay, now if let's say above the diagonal, this is a diagonal, right? Above the diagonals are all zeros, the elements are all zeros, then we call it as a lower triangular. Okay, lower triangular. Okay, so an upper triangular. Okay. Okay, so is that okay for this slide? Especially this one. Okay, so you can see below the diagonal, they are all 0. Okay, so we call it as upper triangular. Okay, can you understand? For upper triangular, can you understand? Because in the later part, we need to involve this again.
Yes, miss.
Miss,
Yes,
for the upper triangular, can you explain again? I don't get it that well.
Okay, so you need to identify, okay, for the matrix, where is a diagonal entries. So can you see I try to highlight here? So here is a diagonal entry. So normally this one is only applied to square matrix, m by m, square matrix. So for example, let's say you have a 3 by 3 matrix, okay? So, okay, let's say I give you an example. Okay, so this one 0, this one 0, this one 1, this one 0, this is 2. Okay, so this is an example for upper triangular. Okay, can you see when you look at this matrix 3 by 3, right? This is a 3 by 3 matrix. Where is a diagonal? Here is a diagonal. Okay, then below the diagonal entries, they are 0. Okay, so when this happens, this matrix, we call it as upper triangular. Can you understand now? Okay, the one below the diagonal entry are all zeros. That is upper triangular.
Miss, I wanted to ask, what does the I bigger than J means?
Okay, so the ij is actually referring to the position. So can you see this one, aij? Aij is the element of the matrix, okay? So can you see A11, A12, A1n, okay? So the I, which is represent the rows, and the j represent column, okay? So they are trying to say that when the I is greater than the okay, Aij is equals to 0. Those equals to 0 means the I is greater than J. Okay, so for example, what is this position? This one is a second row, first column, right? A21. Okay, A21. So can you see this is I, this is J. The I is greater than J. This is means by the definition. Okay, so when you look at the second one, okay, for examples, okay, can you see this one? What is the position? First, second row and first column. So this one is third row and first column. So how about this one? This one is the third row and second column. Can you see we have A21, A31, A32, the 2 greater than 1, the 3 greater than 1, the 3 greater than 2. Okay? Okay. Any other question? Clear?
Yeah, clear, miss.
Okay, then lower triangular is opposite. Okay, so if you understand upper triangular, then I think you can understand lower triangular. Okay, now next one. Transpose of a matrix. Okay, what is means by transpose of a matrix? So when we say transpose of the matrix, the notation is a superscript of T. Okay, the T is come from the initial letter of the transpose. So transpose means we will interchanging the rows and columns. Okay, interchanging rows and column. So for example, if you have matrix A, right, the first row is 1, 2, 3. Okay, so the first row become the first column. Okay, then for the second row become the second column. Okay, so this is means by transpose. Okay, understand?
Can you explain it again?
Okay, so when come to transpose means you interchange the rows and columns. So for example, can you see what I'm just showing here? Okay. For example, matrix A, the first row is 1, 2, 3. So what is a transpose of A? The first row become the first column. Okay, then the second row become the second column. That is means by transpose. Okay, that is means by transpose. So for example, let's say I have another matrix. Okay, so 1, 3, 0, 4. What is a transpose of B? Okay, so can you see the first row will become the first column? Then the second row will become the second column. Get it? Okay, okay. Now, next, okay, next one is a determinant. Okay, so okay, you need to understand about determinant so that you can find the inverse of the matrix. So when we want to find the inverse of the matrix, we need the values of determinant. Okay, so let's start with a 2 by 2 matrix. Okay, so how to find the determinant of the 2 by 2 matrix? Okay, for your information, if you want to, what is the notation for determinant? The notation is a straight line. Okay, so let's say you have a matrix of A11, A12, A21, A22. If you want to indicate determinant, you write it with 2 straight lines. Okay, that is a notation for determinant. Okay, how we find determinant? Okay, so we can use the this and multiplication of these elements and subtract with the multiplication of these elements. So can you see I put a cross? Okay, so it's already given here. A11 times A22 minus A12 times A21. And always remember, it's a subtraction. Okay, it is a subtraction. Okay, now let's have examples here. Okay, so now say we have 1, 2, 3, 4. Let's say you want to find the determinant of 1, 2, 3, 4. So can you see I put a cross? Okay, that means 1 times 4, okay, minus with 2 times 3. Okay, and always a subtraction. Okay, so you get a -2. Okay, so that is 2 by 2. Okay, Samuel asked, how about 3 by 3? Okay, 3 by 3 won't be that simple already. Okay, 3 by 3, but for the 3 by 3 determinant, you also need to understand 2 by 2 determinant. Okay, so later I will explain. Okay, you need to understand 2 by 2 determinant so that you can do 3 by 3 determinant. Okay, is that clear so far for 2 by 2 determinant?
Clear, miss.
Clear? Okay.
Yeah, miss.
Thank you. Okay, so if you are clear about 2 by 2, okay. So before come to, okay, we will continue with the inverse of the matrix. So as I say just now, determinant of the 2 by 2 matrix is required when you want to find the inverse of 2 by 2. So let us complete the inverse of 2 by 2, then we go to determinant of 3 by 3. Because after you learn about determinant of 3 by 3, you will continue with the inverse of the 3 by 3 matrix. Okay, so for the inverse of the 2 by 2 matrix, okay, so this is the formula, okay? So when you want to find the determinant, is 1 over determinant of the matrix A. So let's say you have a matrix A, you want to find the determinant, okay? Then is 1 over determinant of A, okay? And then can you see what happened to this part? Okay, for your information, this part, we call it as adjoint of A. Okay, we put it in the short form. Adjoint of matrix A. Okay, so what is the adjoint of matrix A here? Can you refer to the original matrix, A11, A12? So the adjoint, how you find the adjoint of the matrix A? These two will be swapped. Okay, these two elements will be swapped. And then for these two elements, we will inverse the sign. Can you see we have a minus? Okay, so that means if let's say the elements of A12 is a positive, then the adjoint will become negative. If let's say this is a negative, then will become positive. Okay, so for example, now let's look at these examples. Okay, so how we actually find the determinant? Sorry, the inverse. Okay, so first we will find the determinant. Okay, so remember determinant means -1 times 2, which is equal to -2, minus, then 0 times 1 is a 0. So your answer is -2. Okay, so the determinant of the matrix is equal to -2. Okay, so next one, how we find the inverse of the matrix? So inverse of the matrix is 1 over determinant, which is -2. Okay, then here will be the adjoint of the matrix. So what is means by the adjoint? So can you see we need to swap these two? Swap their position. So -1 become here, 2 come to here. Okay, swap these two elements. Then for these two elements, we will inverse the sign. For 0, we still remain as a 0 because 0, we don't have a sign. But for 1, since you have +1, it becomes -1. If you have -1, become +1, inverse the sign. Okay, so this is the 1. Okay, then what is the next? Okay, then you will multiply each element with negative 1 over 2. So can you see this one become the scalar multiplication already? Okay, scalar multiplication. So each one of them will multiply by negative 1 over 2. So when 2 multiply by negative 1 over 2, you get negative 1. 0, then is still 0. Then negative 1 times negative 1 over 2, you get 1 over 2. So negative 1 times negative 1 over 2, you get positive 1 over 2. Okay, so that's how we get the determinant. Okay. Okay, so is that clear?
Yeah, miss.
Okay.
Clear, miss.
Yeah. Okay, so now I think before we move on,
Excuse me, miss.
yes.
Can you please re-explain it?
Okay. Okay, which part? Can you understand the adjoint part? Can you understand this part?
No, miss.
Okay, so how we actually get to this part? As I say, we swap these two elements. Understand?
Yes, yes, miss.
Okay. Then these two, another two, we inverse the sign. Positive become negative, negative become positive. But for 0, because 0 have no sign, okay? So we just ignore it. For 1, it become minus 1. Is that clear?
Yes, okay, miss.
Okay. Then this part is a 1 over determinant. The negative 2 is a determinant. Clear?
Yes.
Okay. Then you need to multiply each element with negative 1 over 2. So 2 times negative 1 over 2, you get negative 1. Clear?
Yeah, okay, clear.
Okay, so 0 times negative 1 over 2, you get 0.
Yes.
Okay. Then negative 1 times negative half, you get positive half. Clear?
Okay. Yeah, okay.
So same things.
I got it, yeah, yeah.
Okay.
Got it. Thank
Okay.
you, miss.
Yeah. Okay, now before we move on, okay, before we go for break, so I want you to find the inverse of the matrix for this. Okay. So let's say I give you this question. B equals to this one. Okay, can you find the inverse of the matrix now? Let's do it now. Huh? So what is the first step? What you need to do? Find the determinant B first. Okay, then you find the inverse. So I give you a few minutes. $22. Okay, 22 is a determinant, right? Yep, correct. Okay, so how we find the determinant? Okay, remember, as I say, we multiply by crossing. 5 times 2 minus negative 4 times 3, right? So it's equals to 10 minus negative 12, so which is 22, correct? Okay, now get the inverse. How we find the inverse? Okay. So 1 over determinant, 22. Okay, then, okay, we need to swap these two. Okay, become 2 and 5. Okay, then for these two, we need to inverse the sign. Positive 3 become negative 3. Negative 4 become positive 4. Okay, then bring in the 1 over 22. Okay, so each one of them multiply with 1 over 22. Okay, so the first one 2 over 22. The second one negative 3 over 22. So 4 over 22, 5 over 22. Okay, then your final answer, simplify it, 1 over 11, negative 3 over 22, 2 over 11. Okay, then 5 over 22. Yeah, okay, so students give their answers in the chat box. Okay, yeah, they are correct. Okay, yeah, good. That means you understand already. Okay, so I give you a 10 minutes break. Okay, later we have a lot of calculation to do. Okay, so that will be the later part. Okay. Okay, so give you 10 minutes break. Okay, so we continue after 10 minutes. Okay, students, let's continue. Okay, let me take the attendance. Today is T4. Okay, mark your attendance. Five more students. Three more students. Benny, Benny, are you here, Benny? I thought he's here just now. Ziyi, Ziyi, Dang Kai Feng, Dang Kai Feng. Here, okay, so I take your attendance. Okay, Ziyi here, okay. How about Benny?
Yes, Miss, I'm here.
Okay. Okay, so that means all students are here. Okay, let me continue. Okay, so let's continue the determinant for the order of 3 by 3 matrix. Okay, let me show you how to find the determinant first before we proceed to the inverse of the matrix. Okay, so I will take this as an example. Okay. I'm using the. Okay, for your information, for 3 by 3 matrix, right? There are 6 ways to actually find the determinant. Okay, so 6 ways. Okay. Okay, so determinant of A, 3 by 3 matrix, we're also using 2 straight lines. Okay, so how we actually find the determinant of 3 by 3? Okay, then you need to understand the sign pattern also. Okay, this one is a sign pattern. Okay, minus, plus, minus, plus, minus, plus, minus, plus, and minus. Okay, so these are the sign pattern. Okay, sign pattern that you need to take note. Okay, hey, hold on, sorry. Mistake. Okay, yeah, correct. Okay, so this is a sign pattern that we will follow. Okay, so now, okay, let's say, okay, I choose to use first row. Okay, so can you see when you look at the first row, this is a sign, right? Plus, minus, plus. Okay, so that means it is plus, then minus, then plus. Okay, right? I follow the sign, plus minus sign, plus minus plus. Okay, next one. What is the numbers of the first row? 1, 2, 3. So I put 1, 2, 3. Okay. Okay. Next, I put the sign of the determinant. Okay. So now, let's say, okay, so I start from this part, first element, right? This one, first element, right? So when involve the first element, I block the first row. I block the first row, first column. So when I block the first column, can you see these are the 4 elements? So which is 5, 8, 6, 9. Okay, 5, 8, 6, 9. Okay, so now come to the second one. Okay, this one, okay, so this is the number 2, right? Okay, come to this one. I block the second column. So can you see I have 4, 7, and 6, 9. So I write 4, 7, 6, 9. Okay, 4, 7, 6, 9. Okay, so next, okay, come to the third. Okay, this one. So that means I block this column. So can you see these are the 4 elements? I write 4, 7, 5, 8. Okay, 4, 7, 5, 8. Next. Okay, then I will proceed to do the calculation. Okay, so now, can you see how to find all these things? Okay, these are determinant, 2 by 2 determinant. Okay, all these one are the 2 by 2 determinant. So that's why what I'm trying to tell you just now, you need to know how to find 2 by 2 determinant in order to know how to find 3 by 3 determinant. Okay, we have a positive 1, right? Okay, so then the determinant, 5 times 9, 45, minus 6 times 8, 48. Okay, then this is positive 1. Okay, positive 1 when you multiply is still the same. Okay, so you can ignore it. Okay, next one, minus 2. Okay, what is the determinant? 4 times 9, 36, minus 6 times 7, 42. Okay, then next one, plus 3. Okay, the third one. Then the determinant, 4 times 8, 32, minus 5 times 7, 35. Okay, then find the answer. Okay, let's calculate now. So the first one is minus 3. Then this one is a minus 6. This one is a minus 3. What is the final answer? Is it negative 18? Okay, you get a 0. Okay, so for this case, you get a 0. Okay, okay, so yeah, okay, you get a 0 here. Okay, that's how we actually, okay, I think this is not a good example. Why? Because for these questions, right, when we get a 0 for determinant, that means the matrix do not have an inverse. Okay, do not have an inverse. Okay, doesn't matter. Let me try on other. Okay, so, okay. There are 6 ways. So now you say you want to give up on others way. Okay. So let me show, because this one, Okay, can I have, let's say I'm using this one. Okay, anyway, later you are going to use it for the calculation. Huh? Okay, so the first one actually is the one that I always use. Okay? Yeah, so when I say different way means you can, using the same concept, you can use second row, you can use third row, you can use first column, you can use second column, you can use third column. Okay, so but when you're using first row, you have to use the sign of the first row. If you're using the second row, you have to use the sign pattern of second row. Okay, so for example, okay, okay. Okay lah, doesn't matter lah. So I use back this one. Okay, so now let's say you're trying to use the second row. Okay, that means you will use the sign from second row. Okay, so I just show you another way. Okay, that means when you're using the sign for second row, okay, so the sign pattern is minus, plus, minus. So that means minus, plus, then minus. Okay, then second row, the value is 4, 5, 6. So 4, 5, and 6. Then followed by the determinant. Okay, so now, okay, let's say you want to find for the first part, this one, right? Okay, so that means you're trying to block the first column and the second row. So you have 2, 3, 8, 9. So 2, 3, 8, 9. Okay, now, so come to the second one. Okay, so that means you will block the second column. So what you have, 1, 3, 7, 9. Okay, then come to the third one. You block the third column and the second, because just now we choose the second row, right? Okay, third column. So 1, 2, 7, 8. 1, 2, 7, 8. Then you just calculate the determinant. Okay? Yes, you will get the same answer. Okay, you will get the same answer. No matter which row, which column, okay, suppose you should get the same answer. Okay, if you don't get the same answer, means your calculation is wrong. Supposed to be the same. Okay, okay, so can you see when come to different row, if you choose different row, the sign pattern will change. Okay, so normally my practice, I'm choosing the first row. Okay. So I always using the first row because if you keep on changing, sometimes you'll get confused with the sign. Because if I'm choosing the first row, okay, if I'm always choosing the first row, right, okay, I will always remember my sign is positive minus positive, okay, because you're using the sign for the first row, okay. Okay, so because if you always change, right, then you have to remember to change the sign. So this is the one, okay? So if your sign is different, then your answer will be, if you put the sign is a wrong sign, then of course your answer will be wrong. Okay, so my practice, I'm always using the first row. And as I say, you can also calculate by column. So the concept is also the same. You'll get the same answer. Okay, so is that clear? Before we go to inverse, because inverse have a lot of calculation. Okay, now let me give you another question. Okay. Okay, this is our next question to find the inverse. Okay, let's try to find the determinant. Let's do it now. Okay, the sign pattern and the value. Okay, so let's do it now, every one of you, and tell me what is the answer. So as I say, you can choose any row, any column, the answer is the same. But as I say, I always using the first row so that I don't get confused with the sign pattern. Okay, just in case next time if I'm using second row and I forgot to change the sign pattern, then there will be the mistake. And after I'm so used to it, so of course I'm not used to doing column. Column again, you have to follow the sign pattern. Okay. So all students do it now, okay? I will ask the students to, okay, once you get the answer, you can put it in the chat box. But later, I will ask the students to show me I will just pick a student to show me the solution. 26, I don't think it's 26. 22 should be the answer. I remember it's 22 lah. Okay. Okay, so students get it 22. Okay, can I have a student to step the solution for me? Sutesh? Sutesh, can I have your solution?
Give me a minute, miss.
Okay, so 22 is correct. So Excel, you better check your solution again. To be frank, the calculation is not difficult, but this kind of question very easy to have a careless mistake. I have to say that, okay? Because recently my students just have a quiz, okay? That is an old format, okay? This topic, there are 2 quizzes. So I just finished the marking. So I can see there are quite many careless mistakes, okay? So okay, how you actually write the symbol notation for determinant? Remember, we're using 2 straight lines. So if you want to indicate that you are looking for the determinant, so we just put the 2 straight lines. Okay, indicate we are finding the determinant. Okay, so Excel managed to get 22. Sutesh solution still not coming yet.
Yeah, I'm sending right now.
Okay, so let's see the solution from Sutesh. Okay, so now, okay, he using the first row as well. Okay, positive, negative, positive, correct. Number 1, number 2, number 3, correct. Then 4506, correct. 0156, correct. 0410, correct. Okay, then just find the determinant. 24 minus 0, 0 minus 5, 0 minus 4, correct. Okay, then final answer is 22. Yep. Okay. Okay, so now, so I assume everyone understand already how to find the determinant. Okay, then next we will move on to the how to find the inverse of the matrix 3 by 3. Okay, inverse of the matrix of 3 by 3. Okay, so remember as I say just now, okay, what is the formula for inverse matrix? Huh? Okay, so when you want to find the inverse matrix, okay, so let's say for 3 by 3, inverse is equals to 1 over determinant of A multiplied with the adjoint matrix of A. Okay, when come to 3 by 3, also the same. Okay, and before you can find the adjoint matrix of A, you need to find the cofactor of A. Okay, so this is cofactor. So what is means by the cofactor of the matrix? Okay, what is means by the cofactor of the matrix? Huh? So let me show you here. Okay, hold on. Okay, so you need to first step find the cofactor of the matrix. So how we find the cofactor of the matrix? Okay, so can you see we need to take this one. Okay, so now find the cofactor of the matrix. Okay, so it is equals to, okay, so now can you see, let's find the, you need to find the cofactor for each element. Okay, so you have 9 elements here, that means you need to find the cofactor of each element. Okay, so we start with the positives. First row means positive, negative, positive. So that means that's how we find, okay, the sign, positive, negative, positive. Okay, positive, negative, positive. Okay, now, so when I deal with the first row, okay, so for the first element, okay, then I block the first column. I block the first column. So when I block the first column, can you see 4506? So this is a determinant 4506. Okay, then can you see the second one is a minus sign? Huh? Okay, so the minus sign, then the determinant. Huh? Okay, so now come to the second element. So I block the second column. So I have 0156. Okay, so next one, okay, come to the third one. I block the third column. So I have 0140. Okay, okay, now done. Okay, next, let's say I choose the second, come to second row already. I need to find the cofactor for second row. So now this is the sign. Okay, so the sign is negative, positive, negative, negative, positive, negative. Okay, so now we repeat the same things. Okay, so now I start to find the first element. So I'm blocking the first column. So 2306. Okay, then I continue with the second column. I block the second column. So I have 1136. Okay, then come to the third column. Block the third column, 1210. Okay, so that's how I find the cofactor for second row. Okay, now come to the third row. So the sign is plus, minus, plus. So plus, minus, plus. Okay, then same concept. Block the first column, 2, 3, 4, 5. Find the determinant of 2, 3, 4, 5. Then block the second column, 1035. Okay, then I continue. Block the third column, 1204. Okay, so this one we call it as cofactor of the matrix. Okay, cofactor of the matrix. So what you need to do for the next, okay, so let's evaluate the value. Okay, so how we evaluate? Can you see this one is determinant? So for the first one, 4 times 6, 24 minus 0. So this is positive 24. Then next one, 0 times 6. Okay, 0 minus 5. So it's negative 5. Then you have a minus. So positive 5. Okay, negative 5. Then you have another negative, positive 5. Okay, so next one, 0 minus 4 is a negative 4. And continue. Okay, so the second element here, 2 times 6, 12 minus 0. So you have a negative, so negative 12. Okay, so the middle one, 1 times 6 is a 6. 6 minus 3 is a 3, so positive 3. Okay, so next one, 1 times 0 is a 0. Minus 2, negative 2. You have another negative, so positive 2. Okay, and so on. Okay. Can you calculate for the last row? Can I have the answer for last row? Let's do it now. Okay, minus 2, correct. Then next one, minus, okay, the sign for the second one. What is the sign for the second one? Negative 5, correct. 1 times 5, 5 minus 0, then you have a negative, so negative 5. Don't forget the sign. Okay, then the next one, 4 minus 0, positive 4. Yes, correct. Okay, get it? That's, we call it as cofactor. Okay, cofactor of the matrix. Okay, so, okay, so after you get the cofactor, okay, okay, just now we already got the determinant. Just now we already got the determinant as 22. Okay, so now we find the cofactor of the matrix. So we get this answer. So the next, we need to find the adjoint of A. So for your information, adjoint of the matrix A is actually the transpose of the cofactor. Can you see the transpose of the cofactor? Okay, transpose of the cofactor. Okay, transpose. So what is the value we have? 24, 5, -4, -12, 3 and 2, -2, -5 and 4. So when I say transpose, the first row becomes first column. Then the second row becomes second column. Then the third row becomes the third column. Okay, so this is adjoint of A. Okay? Okay, let me check whether my answer is correct. So I just worry that I make the careless mistake also. Okay, so this is the adjoint. Okay, yep, correct. Okay, so next one, we will find the inverse of the matrix by 1 over determinant of A multiply with the adjoint of A. So the determinant just now is 22. Multiply with the adjoint of A, this is the 1. 24, 5, -4, -12, 3, 2, -2, -5, then 4. Okay, so multiply each one with 1 over 22. Okay, so this one will be 24 over 22, then 5 over 22, then -4 over 22. Okay, -12 over 22, 3 over 22, 2 over 22. So -2 over 22, -5 over 22, 4 over 22. Okay, then next, simplify them. Okay, so 12 over 11, 5 over 22, -2 over 11, -6 over 11, 3 over 22, 1 over 11, -1 over 11, -5 over 22, 2 over 11. Yeah, we can cancelling down, of course. Okay, so normally we're cancelling down. Okay, answering the questions from Saad. Okay, so now let's have a look again. Okay, so the first step, okay, we find the determinant of the A. Okay, so remember earlier we already found the determinant, right? Okay. So we found the determinant. Okay, so we found the determinant, right? Okay, then after we found the determinant, then we find the cofactor of the matrix. So cofactor of the matrix, you have to follow this sign pattern. So this is how we find the cofactor of the matrix. Okay, then we calculate. Each one is a determinant for 2 by 2 matrix. So we get the cofactor. Then to find the adjoint of the matrix, we need to find the transpose of the cofactor. Okay, transpose of the cofactor. That means the row become, okay, so can you see transpose means the row become the column. Okay, the second row become the second column and so on, right? Okay, so this is the adjoint of the matrix. Then for the adjoint of the matrix, okay, so we need to put it here and multiply by 1 over determinant. Okay, then this is our answer. Okay, is that clear? Is that clear so far? Any question?
All clear, miss.
Okay, good. Okay. Okay, so we have done the determinant, the inverse of the matrix. Okay, so let's move on. Okay, how we apply this inverse of the matrix in solving the simultaneous equation. Okay, so that is our next part. Okay, so for this one, let's look at 2 by 2. Okay, just now we learned about the inverse of the 2 by 2. Okay, the concept will be the same. Okay, so let's say you have two simultaneous equations, 2x plus 2y equals to 9, 3x plus 6y equals to 12. So that means we deal with two unknowns here. Okay, you need to find what is a x and what is a y. Okay, so how we solve by using matrix, okay? Then you will write the simultaneous equation into matrix form, okay? So at first, we will take out the coefficient, right? So in the first matrix, okay, these are the coefficient. Then after that, you have x and y, right? So you put the x and y in the second matrix, okay? Then the next one, you have 9 and 12, right? So you put it here. Okay, so that's how we write the matrix form. Okay, after you write in the matrix form, okay, then you need to solve for this one, right? Okay, you need to solve for this. Okay, so now let us explain our. Okay, can you see this is what we want to solve right now? Okay, this is what we want to solve. Okay, so that means this one, assume this is A, this is X, this is B. Okay, we want to solve this. We want to solve for the X. So that means when solving the X, it will be equals to the inverse of the A multiplied with matrix B. Okay, solving this one, that means X equals to inverse of the A multiplied with matrix B. So that means if I want to solve the X and Y, it will be equals to inverse of the matrix of 2, 3, 5, 6. Inverse, I'm using a superscript of B, multiply with the matrix of B, which is 9 and 12. Okay, so that's the way we solve it. Okay, and the explanation is given here. AX equals to B, right? Okay, so how we would like to have an X only. So let's say I'm taking inverse of the A multiplied with A. And when I take the inverse of A multiplied with A, I will get the identity matrix. Okay, so can you see when the left hand side I multiply with inverse of the A, so at the right hand side I also have to multiply inverse of the A. And since the left hand side I multiply at the left, so the right hand side also have to multiply at the left. Okay, then the multiplication of the inverse matrix A and A give you the identity matrix. And for your information, identity matrix multiplied with the matrix X, you will get back to X. So for your information, identity matrix times B will be equals to B. Identity matrix times A, you will get A. Okay, so this is identity matrix. So that means X equals to inverse of A times B. Okay, so which I already show you here. Okay, so if you want to solve this, then you will find xy as the inverse of the matrix of 2, 5, 3, 6 multiplied with the matrix of 9, 12. Okay, so that's how we find the inverse. Okay, so the same concept is go to 3 by 3, okay, simultaneous equation or 3 by 3 matrix. Okay, now, so let's look at the questions that we have just now. Okay, so this is what we want to solve, right? Okay. Okay, so now to find the inverse of the A, okay, so assume this one is a A. Okay, assume this one is a A. Okay, so find the inverse of the A, okay. It will be equals to, okay, let's say A is 2, 3, 5, 6. Okay, so how to find the inverse of the A? 1 over determinant. So determinant will be 2 times 6 12 minus 3 times 5, 15. So negative 3. So you get negative 3. Okay, then after that, this one is a adjoint of the matrix. Huh? So adjoint of the matrix, remember, you will swap 2 and 6. So it becomes 6 and 2. Then for the 5 and 3, we need to inverse the sign, become minus 5, minus 3. Okay, so this is what you have, the adjoint of the matrix. Then you multiply by 1 over negative 3. Okay, but if we use this to actually solve for the inverse, solve for the unknown, I will recommend you not to multiply negative 1 over 3 into the matrix yet. Okay, so what you need to do, I will recommend you to multiply these two matrices first. It will be easier to solve. Okay, so you multiply the two matrices here first. Okay, so can you see this? The first matrix is a 2 by 2. Second matrix is a 2 by 1. Okay, then you will get the new matrix, which is 2 by 1. Okay, so first row times first column, you get 54 minus 60. Second row times first column, you get negative 27 plus 24. So at the end, you get negative 6, negative 3. So after you multiply the matrices, you only bring in the negative 1 over 3. So this one will be much more easier to solve. If you bring in the negative 1 over 3 earlier, then you only multiply the two matrices. Then it will be a bit difficult to solve because you may involve some fractions here, okay? So it's easier to solve, to multiply the matrices, followed by multiply the determinant, okay? So can you see now we have negative 6, negative 3, then we multiply each one with negative 1 over 3, then you get the answer 2, 1. So 2, 1 means the x is 2, then the y is 1. So x is 2, y is 1. So that's how we solve it, okay? That's how we solve it. Okay, so the same concept, okay, we use it for 3 by 3, okay? We use it for 3 by 3. So for example, okay, so how you solve for 3 unknowns? Can you see? We have x, y, z. X, y, z. Okay, 3 equations for 3 unknowns. So the concept is the same, okay? We will write all the coefficients in one matrix, okay? So can you see this is a coefficient? So 1x, 2y and 3z. So 1, 2, 3. Then 2 minus 3 and minus 1. 2 minus 3, minus 1. Negative 3, 4 and 5. Negative 3, 4, 5. Okay? Then your unknown is x, y, z. Okay? So x, y, z. And then can you see the value at the right hand side is 533, 533. Okay, so from this one, you will rewrite your matrix as this. Okay, as this one. Okay, then in order to solve for the x, y, z, okay, that means you need to find the inverse of this matrix. Okay, inverse of this matrix multiplied by 533. Okay, so how to find the inverse of the matrix? Okay, remember, just now I already showed you how to find the inverse. So first step, you need to find the determinant of the matrix, and we get negative 28. Okay, then we need to find the cofactors, and just now I already showed you how to find the cofactor, right? Okay, after you find the cofactor, you need to find the adjoint. How to find the adjoint? Transpose the cofactor. Okay, so can you see this one is a cofactor? Okay, so this is a cofactor that we found earlier. Then you need to find the transpose. So find the transpose means the first row become the first column. Second row become the second column, and so on. Second row become the second column. Then third row become the third column. Okay, this is an adjoint. Then what is the next? Okay, final step. Okay, this one is a determinant. Remember, we're using the formula. Inverse matrix equals to 1 over determinant of A times adjoint of the matrix A. Okay, so this one is a determinant we found earlier. And then this one is an adjoint of the matrix A that we found in the earlier slide after we transpose the cofactor. Okay. Okay. Then for the inverse matrix that we found just now. Okay, just now we found the inverse matrix, right? Okay, so this is the inverse of the matrix. Okay, inverse of the matrix, then you have to multiply with 533. Okay, 533, that means the B. Okay, 533. Okay, so then after that, okay, so as I say, we should multiply the two matrices first. Okay, so multiply the two matrices. Can you see this one? The first matrix is 3 by 3. So second matrix is 3 by 1. So our answer will be 3 by 1. So your answer is 3 by 1. So you get this answer. Then you only multiply with the 1 over determinant. You get this answer. Then you found the x, y, z. Okay, so the x is 1, y is -1, and z is 2. Okay. Okay, next is the others method. Okay, so I've done the inverse of the matrix and how we find the solve the simultaneous equation. Okay, so 4:30 already. Okay, you get the idea? So can you see how we applied the inverse of the matrix in solving the simultaneous equation?
Yes, miss.
Okay, so tomorrow is a holiday, so we don't have a class. Okay, so you should continue number 3, number 4, number 5. Okay, and the one using inverse matrix until number 8. The rest is other method. Okay, until number 8. Okay, so that means 3 to 8. Questions 3 to 8. This is your homework. Okay, question 3 to questions 8 or tutorial 2. Okay. Okay, so this one need practice. Okay, this one need practice. Okay, so I demonstrate to you already, but you need to practice it. Okay, and you have plenty of time to do it because since tomorrow is a holiday, I will only see you next week. So next week we will discuss this question. Yes?
Ma'am, for the quiz, we have to attend any class or we have to do the quiz directly?
Sorry?
For the quiz, ma'am, we have to join the any team or we have to just do the quiz separately.
Oh, okay. Okay, yeah, I understand. Okay, for your test later, okay, you don't need to join the meeting. I'm going to dismiss this meeting soon. Okay, so you can get ready for your test later. Okay, so you just go to Moodle, click the link, and attempt the question like how you did it for mock test. Is that clear?
Okay, miss.
Okay, so you don't need to come to team. Okay, so yeah, since you have a quiz to test to attempt later, okay, so I better dismiss your class right now. Okay, so you can get ready for your test. Okay, so
Okay, thank you, miss.
yeah, okay, don't forget about the test. Okay, so 4:45 and you have to submit by 6:45. Anything, please text me in the personal chat. Okay, so I think that's all for today. Okay, bye students and good luck for your test. Bye-bye.
Thank you, miss. Bye.
Hi, miss.
Yeah,
Thank you, miss. Bye-bye. Good luck, everyone.
Thank you, miss. Have a good day.
yeah, same to you. Bye. Good luck.